In a universe so vast that numbers lose their meaning, humanity keeps returning to one question. Are we alone? Not just in a poetic sense, but in a literal physical one. Are there other worlds like ours, rocky, temperate, and capable of hosting life? Among the thousands of exoplanets discovered so far, one small, distant world has steadily climbed to the top of that list. Its name is Trappist-1e, and it orbits a star so faint and unassuming that, at first glance, it seems an unlikely place to look for life at all. About 40 light-years from Earth in the constellation Aquarius lies the Trappist-1 system. At its center is a tiny red dwarf star, cool, dim, and far older than our Sun. Yet despite its modest appearance, this star hosts one of the most extraordinary planetary systems ever found. 7 rocky, Earth-sized planets, all packed into orbits closer than Mercury's path around the Sun. From the moment astronomers revealed this system in 2017, it felt like nature was running a controlled experiment. Same star, same chemistry, same environment, 7 variations. And as scientists studied each world in detail, most were gradually ruled out as hostile or uninhabitable. Too hot, too cold. Atmospheres stripped away, no liquid water, no realistic chance for life. But one planet refused to be dismissed, a small star with outsized importance. Trappist-1 is an ultra-cool red dwarf, classified as an M8-type star. It is only slightly larger than Jupiter and emits about 1/1800th the energy of our Sun, a difference so extreme it's often compared to a candle versus a stadium floodlight. That faintness, however, turns out to be an advantage. Because the star is so dim, planets passing in front of it block a relatively large fraction of its light, making them easier to detect and study. The system was discovered using transit photometry, a technique that measures tiny dips in a star's brightness as planets cross its face. The Trappist telescopes, one in Chile and one in Morocco, initially detected 3 planets. Follow-up observations with the Spitzer Space Telescope revealed the full family of 7 rocky worlds, all roughly Earth-sized. Among these planets, Trappist-1e stands out because of where it orbits. It sits squarely in the system's habitable zone, the region where temperatures could, in theory, allow liquid water to exist on the surface. It receives about 2/3 the energy Earth gets from the Sun, making it neither scorching nor frozen solid by default. But light alone is never enough. Why an atmosphere changes everything. For life as we understand it, an atmosphere is essential. It regulates temperature, shields the surface from radiation, and allows liquid water to remain stable. Without one, even a perfectly positioned planet becomes a barren rock. This is where the James Webb Space Telescope enters the story. Webb was designed to analyze exoplanet atmospheres with unprecedented sensitivity, and Trappist-1 was always going to be one of its most important targets. Using a method called transmission spectroscopy, Webb observes how starlight changes as it passes through a planet's atmosphere during transit. Different molecules absorb different wavelengths of infrared light, leaving behind chemical fingerprints that scientists can identify, even from tens of trillions of kilometers away. Thanks to the star's faintness, Webb's data from Trappist-1 is roughly 10 times more sensitive than similar measurements taken elsewhere. This allowed researchers to quickly rule out atmospheres on some planets in the system. Trappist-1c and d, for example, appear to be airless or nearly so. Trappist-1e, however, was different. What we know and what we can rule out. After multiple observations, scientists were able to eliminate several atmospheric scenarios for Trappist-1e. It does not appear to have a primordial hydrogen-helium atmosphere, the kind planets are born with. Those light gases were likely stripped away early by stellar radiation. It also does not resemble Venus, with its thick carbon dioxide-dominated shroud, nor Mars with its thin and fragile atmosphere. Strangely enough, this is good news. None of those atmospheres would be friendly to life. The most intriguing possibility is that Trappist-1e hosts a secondary atmosphere, dominated by heavier gases such as nitrogen, with greenhouse contributors like water vapor, carbon dioxide, or methane. If surface pressure were similar to Earth's, this atmosphere could transport heat from the planet's permanent day side to its eternal night side, potentially allowing liquid water to exist globally, even though the planet is likely tidally locked. That would be a historic discovery, a world of extremes. Tidal locking means one hemisphere of Trappist-1e always faces its star, while the other never sees daylight. In extreme cases, this could result in a scorching day side and a frozen night side, with little in between. But climate models suggest that with the right atmosphere, heat could be redistributed efficiently. There is also another possibility: Terminator habitability. In this scenario, life might exist in a narrow band of perpetual twilight between day and night, a ring around the planet where temperatures remain stable and moderate. Even surface water may not be the only option. Trappist-1 could resemble icy moons in our own solar system, such as Europa or Enceladus, with a subsurface ocean heated by internal activity. Volcanism and hydrothermal vents could provide energy sources similar to those believed to have helped life originate on Earth. From almost every angle, life remains possible, the star that both gives and takes. Yet there is a major complication. Red dwarf stars are violent. Trappist-1 produces powerful stellar flares far more frequently than the Sun. Events comparable to Earth's most extreme solar storm, the Carrington event of 1859, may occur every couple of days in this system. Over time, such flares can erode planetary atmospheres, stripping them away molecule by molecule. Red dwarfs also have incredibly long and turbulent youth phases. Trappist-1 is expected to burn for around 10 trillion years, but its early period of intense radiation may have lasted billions of years. If a planet fails to build a stable secondary atmosphere during that window, it may never manage to do so at all. This raises a sobering possibility. Trappist-1e may simply be a cold, airless world that looks promising from afar but is lifeless in reality. A subtle reason for hope. And yet, the same stellar violence that threatens life may also help create it. Ultraviolet radiation from flares can drive chemical reactions that produce RNA building blocks, essential components of all known life. Now that Trappist-1 has entered a calmer phase of its life, those earlier energetic conditions may have jump-started chemistry without permanently destroying habitability. There is also the question of magnetic shielding. If Trappist-1e has a molten metallic core like Earth's, it could generate a magnetic field capable of deflecting stellar radiation. In fact, its close and possibly eccentric orbit may enhance internal heating through tidal forces, similar to Jupiter's moon Io, keeping its core active and its magnetic field strong. In that sense, proximity to danger may be exactly what keeps the planet alive. So, is Trappist-1 habitable? The honest answer is frustratingly simple: we don't know yet. Trappist-1e could be an Earth-like world with an atmosphere, volcanism, water, and chemistry primed for life. Or it could be a sterile, frozen rock that lost its chance billions of years ago. Right now, the data allows for both interpretations. What makes this planet extraordinary is not certainty, but potential. With additional James Webb observations planned, scientists expect to confirm or rule out key gases such as carbon dioxide in the near future. Beyond that, next-generation missions like the proposed Habitable Worlds Observatory may finally provide a definitive answer in the coming decades. For now, Trappist-1 remains one of the most compelling reminders that the universe is not short on possibilities. Somewhere among the faint red stars, worlds like ours may be waiting, quiet, resilient, and just out of reach. If you enjoyed exploring worlds beyond our solar system and diving into the science behind planets like Trappist-1e, make sure you like and subscribe to the channel. We break down big cosmic questions, real space discoveries, and the hidden science shaping our understanding of the universe. If you want to be smarter every day, like and subscribe, because the search for life out there is only just beginning.